For POD today, why do we rewrite DNA instructions into mRNA first? So who would like to share their answer for that? So why do we rewrite the DNA instructions or make a copy? You could think of it that way too. All right, Evneet, go ahead.
Okay, so I said that we rewrite it so that we can translate it into amino acids.
Yeah, you can't translate, right? If you don't rewrite it into DNA first, you can't translate. That's absolutely true. Did anybody else put that the DNA can't leave the nucleus? Oh, I see some people shaking their heads. Yeah, so both answers would be correct there. You cannot translate unless you've transcribed first. And you could try it. If you have DNA and you try to use your, what did I do? Oh, it's up there. Let me grab my chart real quick. If you just try to use your chart, your little translation chart, without having transcribed the DNA first, you're not going to be able to find anything. There's no T's on here, so you wouldn't be able to figure out what amino acids to connect together. Okay. All right. Who would like to share their answer for number 2? So transcribe what we have here. All right, Serenity, thank you.
I put AUGCAUUCGAU.
Good. And did you do your good habits too?
Yes.
Yeah. So don't forget a line after every 3. Okay. So AUG line, CGA line, UUC line, GAU. Okay. If you weren't here last class and you're like, wait, what the heck? You said that A goes to T. That's only when you're making more DNA. So when we transcribe, which is different, we're making a copy of the instructions into RNA instead. A goes to U. The only time A ever goes to you is if you're transcribing. Okay, that's the only time. Okay. All right, so let's go ahead, jump on in to the transcription and translation practice. So it's this handout right here. I asked you guys to print it out because it's better to write. If you can't print, I told you it's okay. You're just gonna have to type, but it kind of sucks. It's actually harder work to type this time than it is to actually write it by hand. Writing it by hand is actually way faster. And it's going to help you remember it better. Okay, so on the transcription and translation practice, we're going to do a few key things, little tricks here and there to help you remember and fully understand this stuff. So first thing, we're going to draw an arrow from the DNA to mRNA. When we go from DNA and we rewrite it into mRNA, is that called transcription or translation? Okay, so think about your answer. You don't have to say it. You should be thinking transcription. So draw an arrow from DNA to mRNA like this. So you draw your arrow like that. And then next to it, you write transcription. If you're having to type this and you're wondering where I got the arrows, it's up in the shapes. So up here, you can get the little curved arrows and stuff. And this is what I mean. It's so much easier to write this stuff out in this case. So when we go from DNA to mRNA, that is called transcription. If you're asked to do transcription, we say transcribe. When you go from mRNA, when you read the codons in the mRNA and then you connect together amino acids, we call that translation. Okay, so that's step 2. So step 1, transcription, step 2, translation. Can't do step 2 unless you do step 1 first. So those are our 2 steps there. All right, now we're gonna write down some stuff in the don't forget section as we go here. So the very first thing, don't forget, make sure that you fully understand this, is that the DNA instructions say which amino acids to connect together to make the protein. And I'm gonna have to make mine smaller so that way it fits 1 and 2 and 3. Okay, so DNA instructions, sorry, that's there, say which amino acids to connect together to build our proteins. Okay, when we first learned about DNA, we said it's a set of instructions that tell you how to build and maintain a living thing. Then slowly, as we went through the unit, we learned that most of those instructions are for making proteins. And now we can actually physically see, we can do it on paper. We can see that those instructions tell us, first you put this amino acid, then you put this amino acid, then you put this one. And we know that that's important now because the amino acids we connect together will cause the protein to fold into its very specific shape. And if it doesn't fold right because we didn't put together the right amino acids, it has those funky, weird shapes that don't work. Okay, so that's what's going on. That's why we need to know that's what those instructions are. So right here, it's telling us what amino acids that we're going to connect together to build a protein. Now, real proteins are much bigger than this, than what we're going to do. Okay. All right, so let's go ahead and transcribe. So when we go from DNA to mRNA, go ahead and transcribe. I'm going to do it while you guys do it on here. Make mine green so it stands out more. Now, this stuff is so easy. It's really common for the most brilliant students to make mistakes because they go through it so fast. So just a heads up on that. If you go too fast because you think it's really easy, you're probably gonna make mistakes. Even I do. Last period, I was trying to work on something while they were doing this and I tried to catch up and I made a mistake and then someone caught it. I said, yeah, if I make a mistake, let me know because I'm kind of just typing really fast. All right. Now that you've transcribed, you rewrote the DNA instructions in mRNA, go ahead and translate using your chart. Okay, so this is our chart to allow us to translate, because remember, DNA is a language. So this is like our Spanish to English dictionary and stuff like that. This is telling us what that means, what AUG means, what CGC means. And these are all amino acids that you see here. So we're going to find out which amino acids we connect together. So AUG, go ahead, put MET instead of MET/start. Okay, so if you did the first one correctly, AUG, you're going to put MET. Oh, gotta turn off my cap locks. So much easier to write this out than type it. All right, and then don't forget your little dash line. Oh, I forgot. Here, even though we separate them out, don't forget your good habits. Always draw a line. So if you're writing it by hand, which most of you guys are, don't forget your line after every 3, even though it's separated. Just keep that habit. Don't lose that habit. All right, so then do your little dash line to show your strong bonds, which are covalent bonds that are going to hold our amino acids together to build our protein. So then you go CGC, CGC. I got ARG. Another dash to represent a covalent bond. CAU, CAU, HIS, stands for histine. Again, you don't need to know the names of these, just as long as you know that these are amino acids. AUA, AUA, ILE, CAG, GLIN, and UAG. It's going to be stop. Okay. So this is going to be something new. Last class, I wanted you guys just to focus on learning how to transcribe and then translate. Now, a little bit more thrown in here. So every protein that scientists have ever found, when they look at what happens when the transcription and translation occurs, every protein on our planet starts with MET. So methionine, that is the very first amino acid that you will always have. Okay, so it doesn't matter if it's a cow, a pig. Oh my God, I was almost singing that thing from the Princess Frog, the song with the old lady, the cow, a pig, a dog, a goat, had them all in here. Remember that song from that Disney movie? But it doesn't matter what animal you are. So a cow, a pig, a panda, doesn't matter. They all start with MET for their proteins. There's all sorts of different proteins out there, but they will all start with MET. That's a gimme for everything here. Okay, and then we have to find a way to tell the ribosome that, remember, because the ribosome is a place where the proteins get built, we have to find a way to tell them, hey, stop connecting amino acids together. You're done. The protein is already built. So that's where we have what we call stop codons. Okay, so stop codons basically tell the ribosome, stop, you're done, release the protein. So over here, the other two things that we don't want to forget is this. All proteins start with MET. That's why it says MET/start on your chart. All proteins will have a stop codon. Okay, so remember we learned, yes, Wednesday that every 3 bases in the RNA is called a codon, and there's always going to be a stop codon at the end that tells the ribosome, stop, you're done. All right, last new concept that we're adding on here today is trait. So all proteins that you make, remember, they help build and maintain a living thing. So they're either going to physically build, so physical characteristics or traits of the animal or plant, or they are going to deal with personality or daily activities inside cells. So for trait, make up any trait you want. So here is our protein. We've connected together amino acids. And again, real proteins are way bigger than this, but we've connected together amino acids. So we built a protein. It's going to determine a trait, either a personality or a physical trait. So make up any trait you want. It can be about eye color, but don't just say eye color. Say blue eyes, green eyes. You could say curly hair, big nose, small lips, okay, bushy eyebrows. Any physical trait you can think of, that's what you could put right here. So you can make up any one you want. Someone last year rose their hand and he's all, can I say big butt? And I'm like, yes, you can, because that's a physical trait. Okay. So people who have big butts, not just from eating like tons of food, but just like naturally big butts, it's from DNA instructions. That's where it comes from. So yes, that is a physical trait. Okay. So go ahead, put any trait you want. I'm going to put green eyes. Don't copy mine though. Unless you already put green eyes, that's fine. All right. So go ahead, do the 2 boxes. While you guys are doing it, work on your own. And then when you're done, look up to check and see if you got the same thing I did. And then double check my work too. See if I made any mistakes. But don't just copy mine. If you don't know how to do this, you need to meet with me so that way you learn how to do this. Otherwise, you're going to die on the test when we take this. So you got to make sure that you know how to do this on your own. Don't forget your good habits. Line after every 3. UAC. No, it should be TYR. UAC. The chart is in Google Classroom. So if you go to Google Classroom and you go to, oh, this is zoology. I think it's week 15 on Wednesday. Come on, I clicked on it. Let's go. Week 15 on Wednesday, you'll see the translation chart. Can't translate without this chart. You have to have this chart. Okay. If you don't know how to use this chart, don't put it off and say, I'll figure it out later. Talk to me. It's really easy. It's one of those things where if you don't get it at first, you'll have that aha moment and then you'll be like, oh my God, this is easier than I thought it was. So you just need to get that click. You need to get that aha moment. Okay, next one. I probably would have had these done by now if I was writing them by hand. I'm probably going to make a mistake on the second one because I'm trying to go faster. triple U. CCU. Stop. All right, when you're all done with those two, go ahead, take a look at mine and double check yours and double check mine too.